for today, you should be 3/4 done with your drawing. I think that I've got everybody's ideas, and I think that everybody got approval of their ideas, and I think that I've even got everybody's evaluation of their ideas, so that you've narrowed it down to one idea, and you're going to go with it, and that's great. Now you should be in the middle and up to your neck into drawing and designing in 3 dimensions. And we need to talk about that a little bit. Let's just make sure we've got all this straight. Did you guys get my email with the new syllabus schedule? All right, so excuse me. Whew. All right. So today being the 4th, we should have your separate solutions evaluated, and you should have sketches of those as well. And, oh sorry, so that one's supposed to be done today. You should know your one, you should be started on your drawing today. Now, talking about the drawing should be 75% complete by Monday, and then complete by Tuesday. The more complete it is, the more chance we'll have of getting it done, of course. But what we're going to end up doing in the end is converting that drawing into a tool path. And one of the things that we have to be sure is that we have a solid model. And let's take a look at what that means. So here we have several different drawings of parts that have been designed by engineers, and they're designed in a specific way so that they can be built on some kind of a machine. And you'll notice that each one of these models, this is a good one, let's look at this one. Notice that this model here has no openings into the inside of the model. And you can tell that it doesn't because it's kind of see-through. They've made the outside skin of this model here a little bit see-through, so you can see the holes going through, but you can also see the inner walls of the hole. And you've used SketchUp enough to know that when you start stretching things, extruding things, putting holes in things, that sometimes it leaves a hole into the wall of the model. So when you're building your house, for example, and let's say that you were putting a window in, and your wall was 6 inches thick from the inside of the wall to the outside of the wall in the house, and you put your window in, sometimes it cut out the inside, what is called the frame of the window wasn't there, so that you could see between the walls. And that's a problem when you're trying to do some 3D printing with a tool, you're trying to build a tool path, because the printer doesn't know that that's supposed to be solid until you close up that model. So for example, if I was in SketchUp and I went to this side right here, which is all in one plane, and I right-clicked on it and I clicked delete, you would be able to see inside of this hinge or whatever it is, this bracket, and you'd see, essentially into the part that's supposed to be solid metal or solid whatever it is. And you don't want the 3D printer to think that it's hollow on the inside, so you have to close it all up. And once you've closed it all up and there are no openings to the inside that's supposed to be solid, then the 3D printer assumes that everything that is not, it can assume that everything that is not bound by some surface is going to be solid. Everything that's outside of the surface will of course be air, and everything inside of the surface will be solid. And it has to know that, and the way we show it, that is by closing all of our surfaces. That means that you need to be extremely careful when you're designing your model, that you design things very meticulously, that you make sure that your surfaces are all in the same plane and that they connect perfectly. You can't kind of fudge it, or SketchUp will not have a closed model, and when you go to make the toolpath, it will either make a terrible toolpath or it won't make a toolpath at all. So it's an extremely important part of building a design toolpath from a three-dimensional design. Let's see if we can see some other examples of this that will help us to point out anything else here. This is a good example. I have no idea what this part is, except that it has this part underneath. It has this thing underneath here that looks like it's not going to have something printed in it. This area down here that's going to have some open space. That open space, of course, needs to be open space, and when you look at it in the drawing, you should be able to see this funny-looking propeller or whatever it is. However, if you turned it and you looked inside of the propeller, and all of a sudden you could see in one of the ends of the propeller to the inside of the propeller, that you might want to think about, because maybe the propeller is not supposed to be hollow. Anything that you can see inside of from the outside of your model is not a closed surface and therefore will be interpreted wrong in the toolpath. Let's look at some others that might be a little more relevant to what we're doing. The Millennium Falcon. Cool. Okay, here's a good example. So here we have a solid model. What I don't want to do this. I think I've got a virus. Okay. So, in this model you can see that there are a lot of different surfaces that are curved here, and one of the things that helps you to make curved surfaces is putting seams in the surface that connect together. And you can see all the seams that they've put in the surface that kind of connected together. This isn't one surface because of the curvature and other things. So they've seamed it and they've kind of put it together so that it looks like it's a single surface. However, these seams do not always fit together perfectly. And if you've tried to put a roof on a house in SketchUp or something else like that after you've built the house, you'll know what I'm talking about. It's not easy to add things in Google SketchUp. You have to get the lines matched up perfectly, exactly right. Make sure that you do that. Make sure that when you're putting something else on, you're adding a feature onto something in Google SketchUp, that you are using the exact lines. And that's where it's really good to use all the reference points, where you drag your mouse to the line and you reference it, and then Google SketchUp automatically connects to those lines and so on and so forth. So make sure that you're using all those tips and tricks. And it's also a really good idea to try to design your shape using essentially one single two-dimensional drawing, and then using the Follow Me tool or the extrusion tool or the, what do they call it, push-pull tool. Using those two tools to expand that drawing into a three-dimensional object, because then you know that they're all connected and you don't have to worry about having seams that are open or surfaces are not completely closed in. You can also see on this drawing on the front of it, there is this little gap in the front. And that, of course, is supposed to be there on a car. You're supposed to let air in the front of the car to cool the engine. And so we have to assume that that is going to be part of the design, that we're going to have a hole there. And if we were printing this on a 3D printer, it would leave a hole there. However, it might not be thick enough there for the 3D printer to print. The 3D printer has to have at least about, I'd say, 2 or 3 millimeters thickness to any part that you're doing. This won't let me zoom in anymore here, apparently. But so any edge that's going to be a very thin material, you need to give it probably 3 millimeters at least, or about, 3 millimeters being about a millimeter is about a 16th of an inch, so about 3/16 of an inch, maybe a little bit less. So otherwise, there's just not, it just can't squirt enough material on there to make it work. 3/16, 3 millimeters, 2/16 or maybe a little bit less, and 2 or 3 millimeters will give you probably 2 or 3 layers of plastic, and that will hold it together a little bit better. But you can't go much smaller than that. So any parts that have this kind of skinniness to them, or this thinness to them, you need to give them some thickness and make it a closed surface thickness. And it needs to actually have an interior to it that the printer can print some stuff into. Take a look at some other things really quick, just to there are certain limitations to my 3D printer. And this illustrates one of them. Here you have a part that has been drawn so that you have this big arm sticking out over empty space. And if you design this so that this base down here is on the base plate, it would have a hard time printing this because it can't support an arm out there. You need to have some kind of support in there. Now the printer can print some material in here so that it supports the arm, and then when you're done you just cut it out. And that is one way to fix that. Another way to fix that is to lay the part down on a different edge or a different side. So if the back side of this entire part is flat, it might be a good idea to lay it down on that flat edge. It's a really important thing to think about, because you'll get a much straighter, a much more accurate part that way, and also you can avoid having a part that just doesn't print at all. Like it might print all the way up to where this arm goes out, and then when it tries to put the plastic for this arm out, that thing might entirely collapse and not be worth anything. Eventually, we're looking to buy a printer that doesn't have that limitation, that has no problem with support material, doesn't need it, but those cost a minimum of $30,000, and we're just not in the market for it right now. We just can't. We can't scrounge it. The same goes for a part like this that has a hole in the middle, or this. Not a good idea to print this standing up on its edge like this. Better to lay it down so that you can have a flatter edge on the platform. You want to find the best orientation, and sometimes that just takes experience. And so I'm more than willing to help you with that. But you can probably think it through on your own in many cases too. Let me see if I can find any other issues in these pictures that I'm looking at. Well, here's a great example. This would be a great part to print on a $30,000 printer, and it would print it all in one piece, and if there were any moving parts, they would move when you took it out of the printer, just like they're supposed to. And even if you wanted different colors, that would be great, because the $30,000 printer, or maybe $50,000 printer, can print in different colors as well. But we don't have that luxury. If you have multiple parts that are going to be connecting together in some kind of haphazard, or not necessarily haphazard, but more complex way, it might be good to design them specifically so that you can print them separately, so that the print is very simple, and then you connect them together because they've got holes in them for bolting together or whatever. So you might have to work that into your design if you need more than one custom part. And I do want your designs to have at least one thing in them that you need to print on the printer. Maybe it's some kind of a bracket or a spacer, or maybe it's the entire device, I don't care. But something that we can prototype on the printer and help you to build your design with. I guess that's about it as far as things I need to talk about as we're getting our drawings going and we're trying to work towards a three-dimensional toolpath. I'm not seeing anything here that reminds me of any other issues we need to deal with. If they come up, I'll send out an email or we can talk about them on Monday. Yeah, I can't really see much else. Do you have any questions about what we're getting done today and Monday and into next week? Okay. Make sure that you get working and take as much time as you need, because you're going to have a lot of work ahead of you, a lot of work to accomplish by Monday and Tuesday. 75% done by Monday, completed and turned into me by Tuesday. On Wednesday, we'll work on converting to a 3D model so that we can start printing. And then hopefully by Friday, we'll have prints back to you, or maybe by the Monday of finals week at the latest, or something like that. We'll try to get them out, mailed out by the end of next week. So, if there are no more questions, get started on your drawings. Work hard, work fast, and make sure that you're complete with your drawings, particularly in the solid aspect. Make sure that they are solid parts, that they are closed surfaces, closed volumes, so that inside the volume, the stuff that's going to be filled with plastic outside is going to be empty space. And with that, we can be done. Have a great weekend, and we'll see you on Monday. Yep.